The next topic is Coulomb's law. Yes, what is this? Coulomb's law. We can say that this is the basic one in this chapter, and basic one and very important one. You will get many of the questions from this law from for NEET or GW. Any type of competitive question, competitive pattern. You will get questions from this law. Is it clear? Now, don't think that it is a new kind of law. We learned already this kind of law. Like now, here I'm going to take some 2 point charges. This is 1 point charge, and this is another point charge. One is Q1 and another is Q2. And just remember, always point charge means we're going to take positive. Remember, either we can take don't think that here I'm going to take positive charge, clear, but point charges means always we have to take positive charges, clear. Now here what I am saying is, we know this is the positive charge, this is also positive charge, this is positive charge, this is also positive charge. Now the attraction force between these two charges, how the attraction force acts between these two charges, how the attraction force act between these two charges. I think maybe you guys remember F equal to G m1 m2 by r square. F equal to what? G m1 m2 by r square means what? The attraction force, the gravitational force between any two masses, the gravitational force between any two masses is directly proportional to product of the two masses and inversely proportional to square of the distance between the two masses, and this is called as inverse square law. That's what it is, inverse square law. And here also we are applying the same law. Here also will be same law. Here what it is, the attraction force between these two, just we will discuss. Now we know that what is this one, I am giving some names. This is what, this is A and this is B. This is what, A and B. Now this is positive charge and this is also positive charge. Due to Q2, and this is B, this is A. Due to B on A, what will be the direction of the force? Both are positive, so that's why definitely it will repel, means towards out. I mean this one we can say that F force on A due to B. Understanding or not? Force on A due to B, and here force on B due to A. They both are repel, means this is also positive, this is also positive, so that is why these two all repel each other. Now these two charges, the distance between these two charges, we can take it as something like R. This distance between these two charges, we can take it as something like R. Now according to Coulomb, force will be equal to what? Means both will be same, both forces will be same, but in the direction it is opposite. Understanding or not? Here the both forces will be same, but the direction will be opposite. And remember one thing, always force acts along the line joining, force acts along the line joining between the two centers of the charges. Remember guys, here always the force acts along the line joining between the two centers of the charges, means here we can say that this is a line joining between the two forces of the charge. That's why don't think that due to A the charge will act this direction, because don't think it will act this. Due to B the force will act this direction. No, it won't. This direction is not possible, because it is not along the line joining between the two centers. These two are what? Not along the line joining between two centers. Now here one thing we can say is, we have to say is F is what? Directly proportional to q1 q2, means either the attraction or repulsion. Don't think it only repulsion. Here I have taken two positive charges, here I have taken two positive charges, so that is the reason there will be repulsion. If I take positive q and negative q, then it will be attraction. So that is the reason the first point is what? The attraction or repulsive force between two charges is directly proportional to the product of the two charges. What is this? F is directly proportional to the q1 q2. We know the charge already, it is a scalar, no problem. Force is vector. The force is the attraction or repulsive force between two charges is directly proportional to what? Product of the magnitude of the two charges. Directly we can say that what? Product of the magnitude of the two charges. Is this clear? And another thing is what? F is inversely proportional to, F is what? Inversely proportional to, what is R here? Guys, what is R? Distance between the two charges. What is the R? Distance between the two charges. Is it clear? Now once again I am saying the attraction or repulsive force between the two charges is directly proportional to product of the two charges and inversely proportional to square of the distance between the two charges. Square of the distance between the two charges. Now if we combine these two charges, means if we combine these two, like F is directly proportional to q1 q2 by r square. Guess what it is? F is directly proportional to q1 q2 by r square. And here to remove the proportionality symbol, we are taking one constant, that is k in q1 q2 by r square. What is this? q1 q2 by r square. And here there is another thing. Here another thing is what? K is depends on medium, and the value of k is 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught, and the value is 9 into 10 power of 9. Clear? My small 9 into 10 power of 9. Okay. Now here what is this one? This is called as epsilon, and here epsilon naught means permittivity of free space. What is permittivity and all we will discuss in the next classes. Okay, don't worry. Now we need to remember is what? F is directly proportional to q1 q2 by r square. In the proportional, to remove the proportionality symbol, we have taken one constant, and value of k is 9 to 10 power of 9 and 1 by 4 pi epsilon naught. And here the epsilon is what? Permittivity. Epsilon naught, permittivity of free space. Now if we are going to write the definition, what is the definition? According to Coulomb, according to Coulomb's law, attraction or repulsion force between any two charges, the bracket point charges, is directly proportional to the product of two charges and inversely proportional to the square of the distance between the charges, square distance between the charges. Okay, and vector form of the Coulomb's law we will discuss in the next class, tomorrow class. Okay. Okay, bye bye.